evaluate the limit if it exists. And if it does not exist, be more specific and state whether or not the function approaches infinity or negative infinity or neither. All right, so we have the limit as x approaches negative infinity of the square root of x to the fourth minus 1 divided by x to the third minus 1. Now, to evaluate this limit, we're going to use the property that the limit as x approaches either positive or negative infinity of a constant divided by x to the n is equal to 0. All right, so we're going to use this property, which means we want all of our x's in the denominator of a fraction. So what we're going to do is divide by the highest power of x that occurs in this expression, which is x to the third. On top we have x to the power of 2. We have the square root of x to the fourth. On the bottom we have x to the third power. All right, so we have the limit as x approaches negative infinity of x to the fourth minus 1, and we'll divide that by x to the third, but since it's in a square root, instead of x to the third, we'll say the square root of x to the sixth power. And on the bottom of that fraction, let me move this limit so it looks like it's out front of the fraction, equals the limit as x approaches negative infinity. All right, so on the bottom we'll have x to the third power minus 1, and we'll also divide that. But since x is approaching negative infinity, x to the third power is also a negative number. But the square root of x to the sixth is positive, so we'll have to divide by negative x to the third. So now we're dividing the top and the bottom by the exact same number. We're dividing the top by a positive, we're dividing the bottom by a positive. All right, so now let's simplify this and say this is the limit as x approaches negative infinity. So if we combine those two radicals on top, the quotient of roots is equal to the root of the quotient. So that's the square root of, well, we have x to the fourth over x to the sixth. So that's 1 over x to the second power. And then we have a minus 1 over x to the sixth power. So see, now we have our x's in the denominator of fractions on top. And on the bottom, the x to the third over negative x to the third, well, that's a negative 1. And then we have a minus 1 over minus x to the third, or plus 1 over x to the third. Okay, so with a little bit of algebra, we've moved all of our x's to the denominator of fractions. And now what we're going to do is we're going to apply this limit to each of these 4 terms. So formally, applying the properties of exponents, we have the limit as x approaches negative infinity of 1 over x squared minus the limit as x approaches negative infinity of 1 over x to the sixth, and that's all under the square root. So we've taken the numerator of the fraction and applied the properties of limits to move the limit inside of the radical and apply it term by term. And on the bottom, we have the limit as x approaches negative infinity of negative 1 plus the limit as x approaches negative infinity of 1 over x to the third power. All right, so now we have 4 limits. We have this one, we have this one, and this one. So we're going term by term with the limits. And so, because of this property that we're applying down here, we have on top the limit as x approaches negative infinity of 1 over x squared is a 0 minus. The limit of 1 over x to the 6th is also 0. On the bottom, negative 1 is a constant, so that's negative 1 plus. Then we have the limit of 1 over x to the 3rd, which is also 0. So 0 minus 0 divided by negative 1 plus 0 is equal to 0 over negative 1, which is equal to 0. So our limit in this case approaches 0. All right. I hope this was helpful.